Okay, so my name is Roman Rokytskyy. For those who don't know me, I developed part of the Jaybird initially, JDBC driver, and currently I'm the one who supports the driver. The original developer, David Jenks, is no longer with the project for quite a while. So we are going to talk about the new ways of developing the web applications that give you better usability on terms of for the users, but as well as, in my point of view, they simplify the development on the server side. To the background, I have about, 12 years of experience developing on of different projects, basically in web area, but those are the data-intensive projects. The presentation part is rather the one that we do not like to implement because of the efforts involved there to make the things really usable to the people. So we try to reduce it to the minimum possible. But recently there was a change in the technology, which currently I'm really interested in, and we have implemented right now the project, which has great user acceptance, and I will show you the project and explain how you can implement something similar. So our agenda is we take a quick look on the history of web application frameworks in Java. Then we will talk about the Google Web Toolkit, and I will do the hands-on session. We have a bit short time, then I will try to do it as quick as possible and concentrate on the most important things. Is selected frameworks. There's pretty much more frameworks that were developed for the web in last 10 years, about 10 years, a bit more. However, it presents one thing. If things were perfect in this development and there was a silver bullet, there will be probably one framework somewhere around 2005, 2006, and everybody would use that framework. On the beginning here in Java, there was servlet pages that generated HTML code, pretty similar to CGI scripts. The active server pages from the Microsoft world. Then there was first release of .NET, as well as the Struts framework, which tried to split the ideas how to develop the project. Where the main question is, in most of those cases, where do you put your data model? Where do you put your workflow part, business logic, so-called controller, and how do you present that part to the user? Another completely different path was done by Macromedia, now Adobe, with Flash, applets, Flash objects, where you could code it in their framework, and they provided a much more better interactivity for the users. But there were other problems with the framework. One of the obvious problems with the Flash object, you can't really print it on the paper. If you create a business application and it's usable, you have the menu, you have the data grid, and so on. It was more pleasant experience using that part, but you can't really print it, and so on. There was somewhere here, 2005, 2006, development with the Rails. One of the reasons was that the frameworks in Java at that time were so big and monstrous that everything went in the direction of Enterprise, Java Enterprise Edition, which at that time that was Enterprise Java Beans 2.1, more hardware, more power, more. The Rails approach was to bring all that stuff to the bare minimum and to simplify the development of the standard applications without need to code a lot. And the most recent development, it started here as well, was from Google, is the Google Web Toolkit, which is, we will go a bit later and talk about that. But that is yet another approach how to develop the applications. That timeline shows some selected frameworks. Those who visited the, I think that was Firebird Conference 2006, there was a presentation by from the Morphing, Longo, Mauricio, right. The Mauricio Longo made a presentation, a very interesting part. So basically what they implemented so-called code morphing technology. You could code your application in, at that time, 4 different languages: Object Pascal, C#, Java, and Visual Basic, like syntax. And you could compile that into an executable code, and that code generated the HTML code, needed HTML code, and generated the JavaScript code. And the usability of the applications implemented in such a way were quite similar in the browser to those that you develop for the desktop using the Microsoft Access or using the Delphi. This code morphing technology is basically also the same idea that is as part of the Google Web Toolkit. What you have there, you have a compiler that cross-compiles the compiled Java code into a JavaScript code. And that can be seamlessly embedded together with the HTML and executed part on the server side and part on the browser. This is just a smart, short list of different frameworks that you have for rich internet application. One of the interesting things are also this rich IX framework from Eclipse. The idea is the Eclipse framework implemented their own widgets library called SVT. And this rich IX framework is yet another approach to transparently generate HTML and JavaScript code for the compiled SVT applications. And there are some limitations, but if you implement your plugins for the Eclipse IDE, and then there is good chances that you can port your applications to the web part without really doing a lot of coding for the web. At the same time, there evolved quite a lot of JavaScript frameworks, like already mentioned jQuery, the prototype part, the Yahoo user interface library as well, and the XJS component library. These JavaScript libraries also obtained their so-called GVT wrappers, which embed the JavaScript libraries code and provide it as a components library to the Google Web Toolkit. So we are talking about Google Web Toolkit, and that's basically what it is. The Google stated their mission as to radically improve the web experience for the users by enabling developers to use existing Java tools to build a no-compromise Ajax code for any modern browser. So what they provide you a possibility to code every part of your user interface in Java. You code that part with just normal Java components as you would code it for using the SVT or using the Swing. You start the application, you can debug it in your Eclipse IDE. You can put the breakpoint somewhere in the user code. It will stop. You can modify the code with hot code replace, and it will be automatically recompiled and sent to the browser. You can integrate that with HTML and CSS. So basically, it's not the Java components that generate everything for the HTML, but it's the part that allows you to integrate your GVT components together with HTML and mix things together. The GVT components know about the cascading style sheets. The components know about the HTML elements. You can access the outside HTML elements and trigger them to send an event or read the values, replace the values, and so on. It's like a DOM manipulation, but you have normal Java development parts. And what they do when you compile your project as a release part, they generate JavaScript, highly optimized. This is not just a translation of Java code into JavaScript. It's really compilation with linking, with removing the parts of the code that are not executed, with optimizing the execution flow. They also do obfuscating in order to reduce the size of the JavaScript code. If you compile it without obfuscation, then it will take 3 times or more space, and the JavaScript files will be bigger compared to the optimized one. And what they also do, they hide the browser specifics. So the Google Web Toolkit takes care of the most of the browser specifics parts. They take care about browser history management. So basically you can manipulate the history of your browser so your application reacts correctly to the back and forward buttons and so on. How it looks like, just a small demonstration. That's the project that we implemented for our customer. It was done with the Google Web Toolkit with the GVTX components, which is the wrapper for the GVT wrapper for the XJS components. The one thing is they are no longer supported. The project was started in 2008, so at the moment it doesn't really support it, so it's not recommended to use it. This application is this is the administrative part for the thing that manages the clinical trials for the German that are happening in Germany. But I just want to show you here how user interactions are here. The one thing we have to be a bit patient because I have only GPRS connection here at the moment, and basically it should already happen. I am going to check if the connection is there at all. Yes, it is there. But the main idea is that you have your tabs with HTML preview of the generated code with all the possibilities. There's additional parts where you can have the history of the application and so on and so forth. You can create the new trial, which is pretty responsive user interface with all the possibilities. For example, if we have to add the address, we get a nice pop-up. We can create the new address here and so on. As you see, it would be quite hard to get the same responsiveness of the application and the usability with the normal server-generated parts, as well as the help code connected. Well, it loads the online help for the application. So on. This is a production environment. In this case, what I wanted to show you is the audit trail. I need to log in myself again. What it is also possible, what we did is that we are able to generate the difference, the visual difference between 2 versions of our trial that is implemented there, and it's marked, for example, like this. All this is part done in Google Web Toolkit. Same with the user administration, where you can load the users and so on and so forth. Yeah, quite a lot of them here in the slow connection. Back to the presentation. What did we solve in this application? First of all, we improved the responsiveness of the application with the Ajax technology. We are able to load only those data that we need to present to the user, so we are not loading such website would take about, I can imagine, 100 kilobytes or even more. Our loading is reduced to small portions of about 2 kilobytes or something like that. On the development side, we were able to create every component. Each widget is a separate component that is implemented in a modular fashion, and during the development we were able to use the hot code to place in the debugger, which improves the development significantly. Yet another issue that was probably the main reason why we started to think about the Google Web Toolkit is The session management. There was a requirement for the application that it had to survive the crash of the server, restart of the server, but also it should handle quite a high load of the application. Normally, these such of requirements are solved by storing the data in the web session. However, the replication of the web session in a clustered environment usually after some time becomes a bottleneck, and because all the data has to be replicated in a cluster, and if you put just too much data in your web session, then it is a bottleneck for every operation on the web server. What we currently store in the session, we do have the session management, but the only thing that we store there is the username and the password. This is about, I don't know, 20 bytes or let's say 100 bytes that gets replicated in case of cluster use of the cluster for each session. The rest part is done stateless on the server side, and all the state information is stored on the client. The browsers we have modern browsers, we have modern desktops. They have a lot of memory. They have good processors. There is no need to use something to put everything on the server. And the flexibility and the integration, we were able to really integrate with different libraries in JavaScript and so on. So how this is going to work as well. This is a slide that presents architecture of the Google Web Toolkit application. In that particular case, as I say, the RPC, stateless communication, business logic is there. There is a workflow engine and so on. The development, how we are going to develop a Google Web Toolkit application. What we need an Eclipse IDE to develop in Google with GWT framework. We need the plugin for the Eclipse. We will use the Smart GWT library, as at the moment it is some kind of you can think as a replacement for this GWTX library. It's another JavaScript library at the end, but the Java interface level is pretty the same, and the ease of use for the data applications, which are data-heavy applications, in my opinion, it's probably the best one that is available there. And the integration with the Firebird is done via JDBC, our JDBC driver, and the Restlet Framework. So there is a project in Eclipse I have created. I will put this on the CD, but I show you how to create a new project, GWT project here. So in Eclipse, you create the new web application project. It's Google application. We call it FBCon 2010 demo. We keep the same structure as there because I will need to copy code and I don't want to change the package names and fix code a lot. Org Firebird SQL FBCon 2010. We create it with the default SDK. You can use different versions, and we don't want to use Google Application Engine because we will run against the Firebird database. So the project is there. By default, Google Web Toolkit creates an example project there. And the next part that we are going to do is to check whether it runs. So what we have to do, we are going to compile this project. We don't want to obfuscate it. Pretty is good. The compile time is about, I would say, 20 seconds for the projects. With really big projects, it might be 1 minute. However, it's required on the initial compile time, and then when you start to use it in the debugger with the hot code replace, it's done on the fly, and you don't have to restart it again. So the compilation is done and we are starting the application. Hello. Run as a web application. In this case, the plugin starts some web server in the backend, and what we are going to do is to put this part here, this URL. This part tells also the browser to attach the debug session. Without this part, if we strip it away, you won't be able to use the debugger and the hotcode replace. But the application will work as expecting. As you see, there is some CPU time there because it's the debugger session starting. And after starting the debugger session, we will have the name. We have Firebird conference. And we press the button and there is a dialog pop up. That was a server call there. So our things are working now. The next thing that we are going to do is to enable our Smart GWT components. The Google Web Toolkit application is consisting of so-called module. You can consider a module is so to say, the counterpart to the host web page that is going to load this module. There's always a module called FBCon. You can put a lot of different modules. There is a module name. In our case, that's FBCon 20 demo, and then you have the HTML application, which has the same name, and it loads the generated JavaScript part there. So basically that's a combination of what you have. You have the host web page and you have the demo module. What we have to do, we have to copy the Smart Google Web Toolkit modules here. And we have to copy the libraries, which is required. Our part is stored here. In the workspace. We have, this is our library. As you see, it's 10 megabytes big. This library also includes the Java sources, the compiled Java code and Java sources and JavaScript sources of everything. And the Restlet Framework for the server-side integration with the database. And we just copy them to the same place. That's it. No. We refresh the application in order that it notices the libraries are there. And what we also have to put here, this is on the another slide, is the name of the module. We have to initialize the place where our Smart Client or Smart GWT libraries are there. This is very important. Without doing this, you won't be able to start the Smart GWT application. So we have our page here. We copy it from here. Please note that this path is not correct. It must be the name of the module where the data are loaded. So it's in the presentation, and the presentation will be on the CD, so you will have a possibility to look this part there. Now what we are going to do is to copy the small framework that I created to integrate Firebird and the Smart GWT part using the Restful Services. The main idea behind the Restful Services is that the URL that you use, as well as the method, the HTTP method that is sent from the client, defines an operation that is going to be executed on the server side. The URL usually tells the navigation path of your business object. For example, you can have my application / customers / orders. And then if you submit your query parameters to that URL, this is a query parameters to a query that is handling, that is showing all orders of the particular customer. The HTTP protocol defines at least 4 methods. However, only 2 of them are widely supported. You know, everybody knows the GET methods of the HTTP protocol. There is also the POST method to send data to the server side, which the size is usually either multi-part data or when the size is greater than 1 kilobyte. That's the limitation of the GET method. There is also the put methods in order to put some data there, used rarely. And there is also the delete method, which is also used rarely. The idea that was also these RESTful services was the idea of the Rails framework, so that the web application use all the methods. The main problem is that, for example, Internet Explorer normally supports only GET and POST. At least Internet Explorer 6, which is also quite widely used. So what we are going to support, we are going also to support only 2 methods, GET and POST methods, at this part, and we copy the framework, which is these 3 packages. You will have them on the CD. I delete the sources that were generated automatically, since we don't need them. Also, I delete the generated code from here as well. I leave the class file because that's the class file that we are going to reuse later. Now it's cleaned. We copy these files from here to here, as well as I put small configuration file. That's just the way for an example, but you can do it a different way. So what we have there. The problems that is that we have forgotten to add the libraries that we coded to the libraries of the project. This we don't need because it will be started. Okay, so things are fine now, and we have to register. We have to copy a file from here. I will come to this later, and we have to register our servlets that are going to handle our URLs. So we are here. We no longer have the greeter servlet, but we have our RESTful services. So what we are doing, we are here registering a servlet that is going to handle every request that comes to the URL that starts with the name REST. And this is the servlet. What is wrong here? Right, we need JBird. And this servlet is put here. So what we are doing here, there is one method called create inbound route, which is the part that's going to handle every URL. And what we do, we create 2 different areas in our web application. The one is called public area, which is going to handle our login possibilities to our application, and we create another protected area which starts with the relative URL manage, and this protected area has also one part called data source. And in our case, that is going to handle all the JDBC requests. Then there is one more part here, which is the authenticator, which checks whether we were authenticated or not. In our case, we check whether the cookie was set in the application. However, it is not enough. What we have to do as well is to create a converter. The main idea of the Restlet framework is that that it handles in addition to the URLs, it also handles the mapping of the content types that you supply from the client. You can send, for example, the binary data, or you can send the XML data. And it also performs the conversion of the data format, which is sent back to the client. And that is another part that I created. This is an integration for the Smart GVT row set converter that converts the response of the server, the result set that we obtain for our query in JDBC, converts into XML format that is understandable by the Smart GVT project. That is directory, which gets copied also to the source. So basically, we are done with everything that we have to do. What we have to implement, I have talked about the REST URLs. The scheme that you are going to implement, it's free. You can choose everything that you want. What we have here is basically that if a URL starts with manage, then goes the DS, then it is going to be handled by this factory. And in that case, the data source will be passed as the parameter as well as the table name. So you can, for example, have different data sources registered in your application and then access every tables by a table name, and those tables will be presented to the user automatically. We are going to check how things work. And what we are going to do is simply start our application. And we stop that one. We recompile it. However, there's nothing really to compile there. And we start the application and check the response to the data, to our request. How our RESTful integration works. It's called so-called resource. This is our JDBC table resource. It's a small Java class that has two methods, exactly two methods. The one method is we tell that it reacts on the GET request, and it takes the JDBC request class. In our case, it's also the part of our framework, which has the operation type for operations: fetch, update, delete, and insert, append, I think, the start and end row, and the sort by clauses has, and also the list of the columns if we want to note every column in our application. Exactly the conversion from of the request, the HTTP request that comes from the client to this class is done by this conversion helper. Then we extract here the name of the table, the data source. We construct our data source here with the hard-coded login information. You can put this in some configuration that can be also obtained from the session. For example, login information. And this is a helper class that executes query, gets the connection, executes query, and returns the result set. And that's it. We return this JDBC row set as an output, and the converter handles how to convert this Java class into the XML format that is exactly for that client. So you can split the converter in another part, and you can have different URLs handling different frameworks, different applications you can integrate with. You can have the Restlet that is going to handle the web services calls. It's already in the Restlet framework, and you can also put something for your Java applications. Same part for the post methods. However, we check there the operation type, whether it's insert, update, or delete. Otherwise, we use the select mode. Now our part is already compiled, so we start the application. And we are going, the code server is disconnected. So what we are going to do is to say rest. What we are going to access, we are going to do the RESTful call. We go to the protected area, we try to access the data source called foodmart, and we are going to load the customers, because the operation called fetch, and data source food customer ds. However, that's not really important. What is important for us, just a moment, I need to check the names of the start row and row. Start row 1 and row 50. We don't really want to load all 10,000 customers. So it doesn't have the cookie information there. We have to authenticate. At the moment, the password is not checked, but it can be stored in the session, and then you can use this information, extract it from the session or extract it from the cookie, and pass to the data source when you create the connection. So we've got a problem. That must be so. That's basically the response that we obtained. It's a response, status 0, start row 1, end row 50, total rows in the application, what we have, 10,000, and so on. And then we have the information for each record. So that part works. What we are going to do next is we are going to create our user interface. I have created here. The main idea with the smart GVT is that you have to describe to the application, you have to describe your server-side data source, this RESTful data source. You have to provide the links between the data sources. The data source can be considered as a table or as a view. And you can tell that one data source has a foreign key to another data source, and the framework will handle the transparent data loading when you need. So it happens transparently and on the fly. For example, our customer data source looks like this. What we tell which URL to use. One thing is it's case sensitive. Since our customer table name is not quoted, so we have to put it in uppercase. We tell that our primary key is the customer ID. We tell which fields do we have, for example, the password field and so on. And that's it. That's our definition of customer data source. However, our customers have one thing, just a moment. That's foodmart customer. Well, it's not really different. However, what it does have is a link to a customer region, which is another table. And what we tell here is that we set the foreign key to another data source. Then the data source name is specified here, and this is the reference column in the foreign key. The region data source is also quite simple. We tell the URL, we tell the name of the data source, the URL, the primary key, the columns, and we are going to link to these columns. What else do we have here? I just copy all the data sources to our, well, the whole package, to our application. Then we have to create our user interface widgets. They are here. The design of the application will look like this. We have a grid with the customers, and if you click on the customer, you are able to get the detailed information of the customer, and then you can change the region here. So first we have to create this grid. How it looks like, it is the FoodMart customer grid. It's quite simple part. You tell that which data source to use. You specify the fields that are going to be displayed, and you specify the ordering, the size of the page. It does not load the whole result set from the server. It transparently knows where are you positioned in your grid, and if you scroll down, it discovers the position and sends the fetch request to the server to fetch only the portion that is displayed on the client. We tell him to automatically fetch data, and this is another part where we are going to integrate. I come back to this later, where we are going to present a pop-up with the user detailed information. That's basically to the grid. The user details form is also quite simple. What we have to tell is, again, the data source, the fields. We tell which field to display and the label that is going to be displayed there. This part can be loaded, from example, from the resources part, depending on your language, which is configured in the Google Web Toolkit application, so that you have localized resources there. And what we are going to do as well, the combo box of the region information is going to show us the grid with the region information, so we can pick up. This is just an example. In that case, we have a pop-up which is going to display our form. This pop-up only has the cancel button, the save button, and the save button tells the form to save data. That's it. The form then knows the connected data source, and the data source knows how to send the request to the server side, to our RESTful application, which is going to execute the update statement there. So we copy all these parts to our code, and the last part is the application itself. This is the initial application where we create a customer grid, and we also add the button to refresh the grid when the data changed. So we are just putting it here. Well, we are done. Compile. Wait a bit, about 20 seconds, and we will see how our application looks like. This integration with the Restlet Framework. It is an example. I have just created it and released it as public domain. So basically, if you like it, you want to use it, extend it, do whatever you like. There is no license attached there. It consists from two parts. The one part is going to handle the generic JDBC row set. This is a part of the application that handles the request to the database, refresh row, execute, insert, and so on. It's quite simple. And another part, exactly the converter, is handling all communication with the smart GVT. So if you choose another component set and it expects a bit different data format to obtain and use different requests, different parameters for the server side, then you have to only replace these three parts. That's nothing complex. It's, I don't know, about 500 lines or something like that. So the application is compiled, and we are going to start our application. Do we have something running there? Yes, we had something running, which we don't want to have running. We start our application. Demo application. So, in that case, this is the demo. We don't start in debug mode because, it loaded the data from the server. There are some parts. The sorting on the last name is done automatically by the framework, so you don't have to implement this all the part. It sends the information. It is handled by our Restlet library. You have the possibilities different. You can clear sort. You can resize the application and so on. So what we also have this pop-up, which I implemented if on a mouse over event. It's quite simple. If you check the sources, the custom and read. What it tells, it creates a pop-up, and this is a so-called rollover canvas. The main idea is to get the record from the rollover canvas, the current record on which the mouse is positioned, and what we do, we just open this pop-up and we say to it, edit the record. So, we can save it. It didn't refresh the patch. Oh, we had an exception. I need to check it. No, for some reasons, most likely we had an exception here. And the exception is address 1 is not known. Well, maybe I made some mistake when mapping the columns. What works is this one. As you see, you can change the name. It sends a request to the server. And another part that I wanted to show you is a grid, where you can select another city. So the possibilities that you have about the response. All these grids, all the information is fetched automatically depending on your form side. And the only part what you had to do is basically to put the links in the Java code, and it loads the data on the fly from the application. So that's about what kind of applications can be developed. The last things that I wanted to show you is a showcase that is delivered with the framework in the browser, and it looks like this. What we have here is, for example, for the data-intensive application, it's a master detail information. If you click here, you can also get part automatically here. There is, for example, quite nice part which is called data-bound calendar, which you can add some event. There, save event, you can resize, and so on, and it can be persisted in the server. There are nested grids where you can have different applications edited on the fly with all calendars and so on. If you have a grid, you can have different widgets and react on them. For example, display some charts or put some comments there. Data-bound dragging is drag and drop. Duplicates not allowed, yeah. Or you can remove it from here. The grid summaries, you can compute, for example, subsums or averages and so on. Yeah, some visual stuff. It's pretty nice part, pretty nice application, which is you can handle the different shadows here and so on. The demo application is not that interesting. For example, the portals, which you can have different portlets there with different size. If you minimize one, and so on and so forth. So it's quite powerful framework, and the integration with the Firebird database is quite easy, I would say, very easy. And all things that you have to do is just to use this Restlet framework, and you can get really nice web applications with really nice usability. Questions? Okay, and thank you very much.